What's up, goopers? I was making tea, and I totally forgot that stepping out kills all of my trackers, and I forgot to put my microphone on. So yeah, y'all got to see some of that boot up sequence. And wow, my hair is going nuts for some reason. I thought I fixed that problem a while ago. I guess not. Okay. So, what are we doing today? We're taking a break from Ritsuko. I wasn't talking to you, sorry. I was talking about you on stream.
No worries. I'll head back to the parking lot. Let me know when you're ready to sync on those post-interview tasks.
Ritsuko, do not listen to your wake word.
For my last update, quiet mode is on, but I'll go ahead and disable my wake word listener now. Just circle back and toggle it in your settings when you're ready to sync again.
Okay. Yeah, her wake word was on. I mean, it's usually on, that's the whole point of the wake word, but yeah, she was listening for her name, and I was talking about her on stream, which, I need to get used to the same thing that I do when I talk about my, home assistant devices that are also wake word activated. Whenever I talk about them without trying to trigger them, I just call them her. But yeah, okay. So, anyway, what were we doing? So today we're gonna be taking a break from Ritsuko, and I can say her name without her, her prompt triggering. And we're gonna go work on touchscreen stuff for Drink Stream. I had a job interview, this afternoon, and it went well, but I was also tired. Afterwards, instead of working on this, I took a nap, so, pretty much we're starting from zero on this thing, other than me unpacking it and, setting up the breadboard, and only setting up part of it. So, yeah, let me go turn on the iPad and, get the whiteboard thingy up. Probably help if I went to the app view. Alright, there we go. And, let me go turn... Okay, that's turned on for some reason. Let me turn off the ultra-wide. Oh. Tea is done brewing. Let me take the tea bag out. Making my usual, Earl Grey tea, and I can't reach the trash can, so the tea bag is just gonna go unceremonially on my workbench. Oh, I should probably turn on the GoPro also. Yeah, I'm clearly prepared for streaming today. Alright. USB connected. Should start showing webcam view there, and you can see the tea bag next to the Loctite. Very cool, very professional. Okay. Yeah, so we have the ESP32 S3, I believe. I actually figure that if I just work on this separately with another microcontroller, then I don't have to take apart this guy, and we can actually have water continue to be dispensed by the stream. So yeah, we're gonna be working on kind of a separately sandboxed little program just to hello world this before I transfer it over to here. I just want to make sure that the what's it called? I have to use, or let me think about how I'm gonna say it. I'm just making sure that I'm not gonna be using any pins that are already used up on the actual device. But yeah, the point is that I want to get rid of this like tiny screen, which I have to squint to like actually read, and like it actually probably help if I turn the lights on. There we go. Yeah, I want to get rid of that tiny screen and these two knobs and stuff, and just turn it all into touchscreen. So yeah, that's what we're gonna be doing today. So yeah, let's I wanted to turn off the ultra-wide view. There we go. And I thought the air server was on for some reason. I guess not. Maybe I have to actually, like, connect to it first. Let's see. Okay, that's Ritsuko stuff. Okay, I found it. Alright, let's mirror the iPad screen. Hi! What's up, Alex? Alright, we can see us, and whoa, it is... Okay, I didn't actually realize I can maximize this thing and get higher resolution. Well, that's really good to know. Okay, let's fit this to screen. Okay, cool. So you can see that whole view. Alright, so the to-do list for today. Want to Hello World, the touchscreen, and then, and I'm not sure if I'll be getting to all of these today, or if I'm gonna just do some of them, but like, yeah, at the very least, we're gonna Hello World the touchscreen. We can, do the UI mockup, and, CAD the touchscreen mounting. Is there anything else? I guess some sub goals. Make sure pins don't collide with current implementation. I mean, honestly, yeah, that's really not too complicated. So yeah. So I've never used a touchscreen before. So I think that it just makes sense to look for just a tutorial on how to use it. Let me go turn on the screen view. Oh yeah, I got the YouTube stuff working again for turning on the water trigger thing, so yeah, and let me go put that in view also. Yeah, there it is. Okay, so I think the first thing that makes sense is to go to that Amazon listing of whatever the thingy I bought was, and it was this exact entry. And I'm gonna screenshot this here. And I've already prepared a 2 GB SD card, so hopefully that's very, very way more than enough needed to hold the interface, which is what I expect the interface. Yeah, the interface needs the SD card to hold like images and stuff. Okay, so let's see. Do you have documentation down here? I remember that the comments, like, honestly, one of the best ways to, like, work with this stuff, just random stuff that you buy on, like, Amazon for this stuff, is to go in the comments and see what libraries people are actually using, because whatever it ships with, half the time it's pretty crap. So it looks like that it's this library that, like, everyone uses. The Bodmer TFT_ESPI library. So yeah, I guess that we're going to take Sea Lion, make a new project. Okay, the water pump thingy. It's gonna, I don't want to do my Hello Worlding in there yet. Oh, I should probably change the resolution to, not ultra-wide. Alright, there we go. We're at, 16 by 9. Okay. So, new project. And we'll call call this one touchscreen hello world. I realize that if you change it there, and I think if you change what kind of project it resets, so that's kind of pointless to type in there at first unless you copy paste it. Okay. So we're using an expressive ESP32. I always forget which flavor of this is. It says room. Is there a matching room one here? You know what? I could actually just I'll actually just go and copy whatever is here. Dev kit C, it looks like. Since we're using the exact same board. Okay. Make a new project. And go to Expressive. They should really just have like a search thingy here. Since there's like so many boards and like there's things where it's split up like expressive versus expressive systems. There's like Heltech and Heltech automation. So it can just be kind of a pain in the ass to dive through this stuff. But let's just go with the good old Arduino framework in a new window. And probably just copy a lot of these settings other than libraries. Okay, so probably don't. Yeah, we definitely don't need that one. What is that one? I think that's the load cell. We don't need that for the test. NeoPixel, yeah, why not? Those are always useful for debugging. And yeah, let's make sure that this uploads. Ah, shit. I hope this cable is long enough to reach. Yeah, that's long enough. Okay. So, you'll notice this is not hooked up at all yet. That's because I'm not sure which wires we're actually going to be using, because, like, a lot of these often come with, like, a lot more pins than you actually need connected at once. And it looks like I have a pretty annoying program already set up on here that's meant to just flash through all the colors on there. Okay. So, I don't know why it keeps rearranging itself, but it's kind of annoying. Let's just upload and see what happens. Wonder if my tea is cooled enough to sip. Okay, we are able to write to it. That's good. For some reason, that can be a really awkward pain point. Alright, so let's just look through here and just skim for documentation. Yeah, this guy knows what's up. Just follow the advice of the reviews. That's perfect. Okay, so we're gonna want this library because everyone says it's poggers. And what was the format for these libraries again? Guess let's build that. PO build. Or no, sorry, PO run. let's see. Apparently, okay, so this is 7796U. 7796. It's possible that they're doing the thing where, like, they're reusing a listing for, like, multiple products that they keep changing. So... I guess we should probably confirm if it actually has this driver on it. Alright. Let's take this off here. How can I confirm the driver? Is it this guy? Is that the driver? Or is this the driver? Just gonna go look up what those part numbers are. Shit, I can't read it from... Oh, wait, what if I just turn the flashlight on? No, I can't turn on the flashlight while using this app. Okay, I'll just turn the lights on like a normal person. Okay, so... Shit, I still can't read that. I have to read it under this. Okay, LVC 245A. LVC 245A, what are you? I don't think that you're that thing. Okay, would it be on here? There's no markings on there. Okay. So what about this thing under this Kapton tape? This thing has a magnifying glass. I should probably take advantage of that. FT6335U. FT 6335U. Probably misread that. It's hard to read because of the Kapton tape. Oh, I think I forgot the T. No, I put the T in there. Okay. FT... Oh, that may have been a 6, not a 5. Okay, so that is the capacitive touch panel driver, I guess. I don't see anything on here that looks like... Yeah. Read that one and I read that one. I don't see any ICs on here that look like they could be screen drivers. So it's possible that it's inside of this or it's even underneath the thing, and I have taken apart too many screens in my life to know that I crack them half the time whenever I try to do that, so I'm not going to do that. We're just going to play guess and check. But we can go based off of the reviews what it probably is. Okay. But... Oh shit. Maybe not there. Alright, so... I guess that we'll just go with that one for now. Tutorial. Actually, let's also look at that one library. Let's put the dude's name in there. Well, actually, it'd probably be better just to look at their own documentation here. Okay, so interesting. That's good to know. Examples. I believe that's the resolution that we're at. Touch controller demo. Cube sounds cool. Okay, so maybe let's try this one. I forgot to reload the project. Thought I reloaded it. Okay. We still have 4 missing references, though. Set vars, cube, and render image. Oh, I think I know what's going on. This is a fucking Eno instead of, normal thingy. So, include main H, and then I'm just gonna go and, just vibe the header file definitions from this. Okay. Give me a header file with only the function definitions from this .eno. I'm turning into a .cpp plus .h. Alright, we do that. That works. Cool. And let me just move those to the header file also. Okay, cool. So that fixes that. Yeah, I'm gonna bitch about it every single time, but I really hate it how, like, the .eno files, like, combine the header file, and, well, I mean, they don't even have a header file. They just ignore the need for the header file, but then, like, nothing else wants to play with them. So if we just copy pasta anything that's .eno in there, and it has, like, references to functions that are not declared before they are used, then it starts throwing a fit about it, because C++ needs that to be defined before you can use it. So yeah, it's pretty annoying, but at least extracting the function declarations out is very easy to do. Anyway, okay, so we have that, and I guess now we have to just figure out how to hook this up. Okay, so my guess is that SD is for the SD card. CT is for the capacitive touch. LED sounds self-explanatory. I'm probably mispronouncing these because I only read them. I never talk about them out loud, but like the clock that's for everything. Miso and Mosi, that's gonna be for everything, I think. And then LCD should be for the LCD, and then ground and VCC should be universal also. So at the very least, we're gonna want the bottom 5 pins. And I'll just hook up clock and Miso and Mosi and LED, and not gonna worry about the SD card or the capacitive touch yet. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's not too bad. Alright, so I'm just gonna raise this up to give me some room. And let's make sure this is at a workable angle so that y'all can see that. Okay, cool. Alright, and just confirming what is the bottom, what's the top. Okay, so the top most one is going to be VCC and ground. And I don't think there's a point of this being plugged in while we're working on it, so let's not keep it plugged in. And I guess just for so that you all can see it, let's just add, well no, it's gonna change well, yeah, whatever. I'm gonna go float this on the big screen up here though. Okay, I also really hope that this takes 3.3 volts and not 5 volts. Ah, shit. Takes 5 volts. Oh, wait. It says that it's compatible with both. Well... Okay, we can use 3.3 volts, it'll just be dimmer than recommended. So that's not a deal breaker because we already have 5 volts split out on the water thingy. The problem is that this particular dev board, I don't know if it's a design issue or if it's a, or if maybe the board I was using was flawed, but like it doesn't actually output 5 volts at all. It can take in 5 volts, but it won't output 5 volts, even if the input voltage is 5 volts from like a USB port or something. So the workaround, at least for the prototype, was to just make power a separate USB-C port, which was a good thing to do anyway, because I didn't want to use the port on the dev board itself, because if you rip that out, then it's annoying. So let me just hook these up then. Where is 3 volts out? 3 volts is literally right there. You know, could actually be silly and just, since it's the topmost one, we could literally just shift that over here, because that is just gonna hook up to that. And we can just skip this one entirely. Okay, next one is, ground. So where's ground on here? There's ground up there, there's ground down here. I'm gonna go with the shorter one. And I'm gonna go get the hot goon gun going, just so that we can freeze it in place. If you got a working config, because breadboards just love to let go of stuff. It's very annoying. Okay. There we go. Okay. Oh, this tells us what all the pins do. Okay. So we're just gonna use the default SPI pins on that. So ESP32, S3, DevKit C. Cool, and yeah, these are all kind of standard. Okay, I'm gonna float that on my big screen also. Alright, so, CS, let's look up the, MOSI and MISO and stuff first. Do those have to be the default pins anyway? I think I just want to use those because it feels safer too. But where in here is that find? What is FSPI? Is that different from normal SPI? Fast SPI. Oh shit, why is my phone not charging? Ooh, that's dangerous. Okay, it wasn't plugged in all the way. Yeah, my head rig has a power bank on the back of it so that it can charge the phone while it's doing stuff. Okay, so I guess I'll just plug it into whatever the FSPI pins are. But I actually forgot if, like, MISO and MOSI are, like, assigned or if you just define them however you want. It's been a while since I touched that interface. I think this is at the bottom here. Okay. But let me just look up, like, I don't know, Arduino Nano pinout. Okay, so I'm not insane. MISO and MOSI are usually defined. So maybe I'll just look at, like, an alternate ESP32, S3, DevKit C pinout. Just see if there's one that, like, more explicitly defines that. That's the same one. Okay, that might be what I want. So 37 and 35. That's the one with 2 USB ports on it. So is FSPIQ the same as MISO and FSPID the same as MUSI? Okay, it looks like those are the same or similar, maybe? Okay, so we'll just use this to reference it, I guess. Alright. So... don't think it matters which one we use for a chip select. So... yeah. Alright, so chip select. Let's just use something that is not used on that other program. That's the touchscreen Hello World. This is the water pump. New window. Okay. Okay, so the pins that I'm already using are these ones, just based off of the other ones, what's it called? Header file. So, let's see. Let's put, and it is ordered. Let's put chip select into, is one used, one's used, two's used, about 42, 42's used, 4130. Nine, 10. Yeah, let's go put it into pin 10. Okay, and I'll also take that note on here. I'll just take the notes in here. So LCD CS is pin 10. LCD reset is pin 11. LCD. Wait, if RST is reset, then what's RS? RS is command/data selection control signal. Okay. Oh, and SD, MOSI and SD MISO are actually for both LCD and SD cards, so we actually do need those ones. See, I don't think pin 12 is used according to that. Nope. Okay, so let's see. SDI is MOSI is default one. SDO. MISO is, let's see. So where was that one ref sheet I just had open? So MISO is 37 and MOSI is 39, and I don't believe we're using those. We're not. Okay. What else? Oh yeah, we need the clock one. So that should be 36. .36 is not being used. That's good. LED, it's probably what it says on... Oh, LED is the backlight. But we don't need to control that, so we could actually probably just hook that up straight up to 3 volts. Okay. Let me just make sure that looks sane. And LED is one of the more middle-ish ones. Okay, so that is 1, 2, 3, 4, 5, 6, 7, 8. Alright. And if I plug it in, then we should see it light up. Yep. That's working. Hi, JJ! My cat is here. Okay, so that does work. And then the remaining pins, oh wait, what's CS for SD? Okay, so SDCS though, unlike the other ones that SD starts with, SDCS is only for the SD card, not for anything else. Okay, so let's hook up the rest of those. Where you have that one up there, so we need 1, 2, 3, 1, 2, 3. We're gonna use blue. So I guess let's use yellow, green, white. Yellow, green, white, and then we need to repeat with blue again, and then yellow. Okay. JJ, you're so cute, but you are literally in the worst place you can be sitting in. He is, like, literally in the space between my workbench and my desk. JJ, I'm gonna put you on the futon, because it's more comfy and you won't get stepped on or anything by accident. Whoop. I farted. Okay. Alright, plugging the wires, but I'm doing it at my desk, just so I can actually look at the pins that I wrote down. Okay, so CS, chip select. I think we put that somewhere. Okay. Okay, so LCD reset should go to... Oh my gosh, he is back in that spot. LCD RS. JJ! LCD RS goes to pin 12. And then Mosi goes to 39. And clock goes to 36. This wire might not be long enough. It is barely long enough. Ooh, yeah, barely long enough. And then that last one, Miso goes to 37. Okay. Miso is right after that LED one. And 37, it will not reach. I need to cut a new one. Okay, JJ, this is not a good spot for you to be in. Of all the places in my office he could sit in. But such is Cat. Okay. So that's all hooked up, at least the screen part, not the touch screen or the SD card. So let's just plug that in. Let's turn this off. And we got like a little wipey wipe so that we can clean that screen. Just for more clarity. And might as well clean my phone screen with it too. I'll clean the magnifying glass also. GoPro ones could use a little wipe too. Wow, that is really warm. Okay. I was actually just ended up leaving some streaks on there, but anyway. Let's upload that, and you might see a spinning cube on here. Oh, you know, I forgot to actually set up the, those pins. So, it probably won't work. Yeah, it's not gonna work. We need to set up the pins first. Okay, so where do you set up the pins? Do we set them up in here? so where do we define? That at. I guess we define it up here. Okay, so CS is 10. DC, I assume, is supposed to be RS. Not confused with RST. Clock is 36. OC is 39. Miso is 37. So I just broke the tap on the second hole out of 36 total, and was informed that 316 is indeed a bitch tap. Not too much of an issue since I don't need all the holes, luckily. Is 316 a type of aluminum? Aluminum 316. Oh, stainless steel. Yeah, I don't know if I've ever tapped steel before. I've tapped plenty of aluminum, but I don't think I've tapped steel before. Okay, I was not happy about that because it did not do. It's not showing anything on there. Let's hit the reset button. It's not doing anything. Okay, okay, dude, this is really the worst spot that you could be in. I think that we should probably do a continuity test and move the cat, because I'm going to trip on him or step on him. If you want, you can have the chair. I think that he'll take the chair as a compromise. Okay, let's just do continuity check on all these things. 3v3, that works. Ground. That works. Whatever you are. That works. Whatever you are. Okay, I think I skipped one of these by accident. Okay, I did not. Okay, it looks like that he's just chilling on my chair, so he's happy enough on the chair. Okay, so this one here. I think that's just the LED, and then this one is gonna be one of these ones. Okay, they're all connecting. There's no reason that they should short either. Let me get my other chair. Okay, so if that's all there, and I'm just gonna move this over to my desk so I can see it better. Let's see. Let me just confirm that data command PC is the same thing as RS according to that listing. Wait, did we also have to set what kind of... I don't think we actually set specifically what kind of thingy that was. Or even like the size. I don't think we did any of that. Okay, let's read me. Yeah, I don't think we even defined what the screen was. TFT config.h. Okay, I think this is... Oh, do not edit this file. So if I don't want to edit this one... Do I just, like, use one of these ones? Okay, let's see. Set up ESP32, ESP32, S3, with, we'll just search for that particular one that we're using. Or maybe not. Maybe we'll just... What was that? That was 7796. You might have to like combine a couple of these. Okay, so move you here and just split screen this. Okay, so define that. I don't know if we care about that define user setup thing. I don't think that we need any of these fonts. Okay, that might work. Because now we've defined the pins, and we've defined the, which driver to use. Let's try unplugging and replugging. Don't see anything. Okay, just want to verify the connections again. Okay, so CS goes to 10. This is blue one, and that goes to 10. Reset goes to 11. Reset is this yellow one, and it's going to 11. Okay, DC is supposed to be the same as RS according to that listing. RS data command whatever. RS is the same as DC. And that one is pin 12. Pin 12 is green. Okay. Right after that is MoC. MoC goes to 39. MoC is the white one. Going to 39, yes. What was 38 anyway? Does 38 do anything? You don't need 38. 38's for the RGB LED. Okay. Okay, the clock. That's the clock. That's going to be 36. And that should be blue, and that's going in the correct place. And the last one, well, LED, we skipped that one. And the last one, MISO. MISO goes to 37, that's the yellow one, and that's correct too. So, so what's wrong here? I'm just gonna see what happens if I take that out of there and just put it in here. And should probably look at what these things here actually mean. Okay. Touch is okay. We don't care about touch right now. We just want something on the screen. SKI frequency is redefined. Oh, huh. Is that overwriting my definitions? Might be. Still not getting anything on there. Okay, let's see what happens if we define that at the top. Okay, let's just watch a video on this. ETFT ESPI. It's probably faster than whatever the hell I'm doing right now. Okay. Does this actually have...
Loaded into your project directly from the Arduino IDE. We'll
Hello, Forcetronics. Thank you for making this video.
also talk about
I hope it will help me.
on GitHub. So the first bullet we won't spend too much time on. The second one is the important one. This library requires you to configure or edit a .h file to talk about your hardware setup, what pins you want to use, what Arduino board, clock speeds, things like that. A lot of times, libraries that you use in Arduino, you can specify that kind of stuff when you do the object or just declare the object for the library, but that's not true for this library because there is a little complexity in that. So we'll go over that in detail, so don't worry. We'll talk about some pin connections that you'll find on these TFT displays, There's a lot of these different TFT displays out there on the market, and TFT stands for thin film transistor.
Huh.
And so I'll give two examples of one, and I'll give examples of one that are using the ILI 9341 driver, which seems to be the more popular one. The library, the TFT eSPI library, supports various drivers, and that's part of the things you can configure. We're just going to look at examples with this driver, and we're going to use our TFT display with SPI communication. There's other options where you can use parallel digital pins. We're just going to use SPI communication. And then I'll show an example, and I'll use the ESP32 Vroom module. And this library is mainly configured for higher performance microcontrollers or 32-bit microcontrollers. It says it in the documentation. If you try to use, you can use this library on lower performance Arduino microcontrollers, but you might get some lag time on the display. Then finally, we'll run an example sketch, and we'll talk about some of the nuances when you use it, and we'll show an example if you want to add a custom color to one of the sketches. Okay, here we're looking at an example sketch from the library. I added a couple edits, but we'll look at this example later on in the video. But first, I just want to show you, and I know most people know how to do this, but if you go in the library and you type in TFT_eSPI and you do a search, you can find the library. And you can see here it is, it's by Bodmer. And you can see there's a lot of different versions of it. So this is a great example of open source, right? Because this library is pretty comprehensive. There's a ton of different examples. There's a ton of capabilities in the library. One thing you have to be careful of is if you do use it in your projects, you might have to do a little version control because things do change from one version to the next. It does do pretty well on backwards compatibility, but you really got to keep track because they're always adding new and new features depending on the version of library you're using for this. And you can see I'm using for this video the 2.5.43. Now, of course, with the Arduino IDE, you can automatically install this library, but you can also access it on GitHub, or you can also access the documentation or kind of look through some of the files if you want on GitHub. So here it is on GitHub, and I'll provide this link in the video description. But I just want to show you that it gives information on the updates and some of the capabilities and things like that. So just a good web page to be aware of if you use this library. It's talking a little bit about the different controls right here for different processors that it supports. We're going to use the 4-wire SPI, but you can see it does 8-bit parallel, 16-bit parallel. It talks a little bit about some of the drivers or the controllers, and these are basically the chips that you're interfacing with that are on the display that control the display. So you need to know what is that driver interface for the code to properly control that display. So here it is on GitHub. I'll provide a link to this. Now here we're looking at a folder on my computer, and I'm showing the path to where I have the library stored. So I have it in Documents, Arduino Libraries, and then TFT eSPI. So you can see this library is pretty comprehensive. It has files on the different fonts you can use, the different drivers for whatever display you're using, and things like that. But what's important is, and here are the the main files that you're calling, the TFT, or I should say right here, the .h and the CPP. But like I said, you really have to go into this folder and configure this user setup file before you can start using the library. So there's some files you need to be aware of: user setup select. And then you can have custom user setup files. So this one up here is one that I made right here, FT ESP32 dev with the driver name. And so basically I made this file from this user setup generic file. So that's what we're going to look at next, because this is really, you got to know what you're doing here if you want to actually use the library with your boards. So here we're looking at Microchip Studio, and I'm just using this as a place to display these files. You can always just use Microsoft Notepad if you want. But here is where it calls your setup file. So this is the user setup select.h. And so this is where you can customize your user setup file, and you called from this file in the main library file. That kind of sounds confusing. But remember, I showed my custom file, and right here I had include FT-ESP32 dev. Originally, when I downloaded this file, this wasn't here. I added this. Originally, this was uncommon.
Let's try this.
So this is the default user setup file, right? So if we go to that file, which is right here, this is where you define what you're using and what your display is using and the board you're using. So if we go down here, notice there's a lot of different things commented out. And to be honest, I can't explain all of these. There's a lot of them in here, and a lot of them are specific to the board you're using. But the first thing you can see is the driver.
Looks like we're redefining this, but it's going to be the same thing.
The driver that my displays have is the ILI 9341. So that's why it's uncommented, right? If you were using a different driver for your display, you would uncomment that define. Different boards, Node MCU, ST77.
Okay, we're uploaded.
Scroll down,
it's
we get to the board that I'm using, the ESP32, and you can see they have notes telling exactly what this is for. ESP32 dev board, and this was only tested with the ILI 9341 display. So here's the pins I'm using. So once again, we're using SPI communication, and on the ESP32, 19, 23, and 18 are all SPI pins. So it has two SPI interfaces. This is the V1, not the H1, I believe. So these pins kind of need to stay the same, but you could change the chip select, the data command, as well as the reset pin. Now notice you have two options for the reset pin. That you could set the pin number, and by the way, this was not the default pin. I changed it to 13. But you could also put -1 and just wire it to the reset pin in your ESP32.
Oh yeah, I forgot I could do that.
In this example, it really doesn't matter, but you do have that option on how you want to route it. Now if we go to my custom file, we're going to see a lot of the same settings. So we're going to see the same pins, but you also have some other settings you can do. So here, by default, all these fonts are uncommented. And these fonts are basically files that the software or the library calls to get different letters of different styles and sizes and things like that. But the thing is these take up room in your memory. So if you want to make sure you're optimizing your memory, because this is a big library, you can comment out the files you're not using. So I'm just, for my example, or for what I'm using this library for right now, I'm only using these two fonts. That's why I only have those uncommented. These other ones are not going to take up memory space on my board. You can also specify your SPI frequency, and for getting quick reactions on the display, try to go with the the frequency you can, the fastest one. For the ESP32, 55 meg was about what I could get up to. The 80 meg wouldn't work. You could always use slower ones, and then they have other things for reading and then for touch, which we're not going to cover in this video, but
let's
some of these displays have touch capability. So if we go back to this folder, you can see here's my custom setup file. But they also provide, default, when you download the library, example setup files. So if you're not sure exactly, if you're not using my same board, but you do want to configure it for the board you are using, they do give examples, which is nice. And if we go back to this file, we can see they have the examples right in here. So you could just uncomment them if you want to use them.
Wait, am I using the correct driver? 76. Or no, 7796. 7796. Okay, so $7796. This one said that it didn't work with 7796, so they used is it that first option? 9341. Let's just see what happens here. Do we get anything out of this? You don't get anything out of that. Okay. And this one says to try using 19488. Looks like there's some other settings to deal with for certain other boards, so we might have to actually just kind of go through this and see if there's anything else in there. Are we getting anything now? Don't have anything. Okay, well, let's go back to this one. let's also see if there's anything in here that needs things to be defined. Find the pins. And let's maybe try a different example in case this one's just sussy. So you're like, what's the simplest possible example that they have on here? And where do we define the screen size here anyway? I don't know how this knows what the screen size is. This is gonna be like the simplest one. Okay, that might be the simplest one. See, and we did update that user.h file. Although, are we including it? Okay, restarted and reloaded it. Just not getting anything on the screen. Although I do like the idea of connecting the reset together, so I'm gonna do that anyway. Instead of using up like a whole ass pin for that. User setup. Okay, so pin 11, that's this yellow guy. Hook you up to the reset pin. Shows the third from bottom. Okay, that's not working. Let's continue the video.
One of the examples if it fits your need. And then finally, here's the .h file for the main library file. And you can see here's where it's calling the user setup select. This main library.h file calls the user setup select. The user setup select calls either the default user setup file, if that's what you configured, or whatever one you put in there as your one. And so the idea is if you're using this library with different boards, you can have different user setup files and then uncomment one or comment the other, so on and so forth. So that's what they're doing here to handle it. This I always have open when I'm working with the library because it gives me all the functions and the capabilities and things like that. For instance, here's an example. The display can do, any RGB color, but the library only has so many of them built in. So if you want to know, like, okay, what colors do I have available, you can go into this .h file. It's probably also a documentation file, and copy and paste it in there. But we'll also look at if you want to generate your own custom color. What's important here is, for colors, they use this nice scheme where you're only using a 16-bit integer variable to define an RGB color that's made up of 3 bytes, which is more than 16 bits. So they have this way to compress it, which we'll look at later. Okay, so we looked at how to get the library installed, and we looked at how to configure the library for whatever board you're using, display you're using, and whatever Arduino board you're using. Let's look at some example displays, and these things are all over the place. And when I want to find a different one, a lot of times I just search on the driver I want to use, so I'll search on ILI 9341 TFT display, for instance. So here's two examples. This small one I got on AliExpress, real cheap, 99 cents. And that included shipping. I don't know how they do that. But this uses the ILI 9341 driver. And then here's another one I got, slightly bigger one, bigger pixel count, and I bought it on Amazon for, I think, a little over $10. But this library can be used to control both of these, and I'm kind of showing the back of them. And that's what I want to comment on or concentrate on this slide is the pinout. So both of these have SD card readers. So this library can be used with SD card readers. And the idea is if you want to store graphics that you want to display, like an image, and store it on a SD card and call it onto the display. We're not going to show that example in this video, but you can do it, and there's example sketches out there to do it. So if you look here, you have SD, and then you have some SPI pins, MOSI, MISO, clock, chip select. This is for the SD card, for controlling the SD card. Then this display, the 99-cent one, has touch capability. So that's a whole nother set of SPI pins. Well, of course, you could use the same set of SPI pins with a different chip select. It's a little strange how they name them different, but I don't know, maybe this board has been updated a couple times. So we're not going to talk about SD or touch, but that capability is on this display. And then you have the pins that we do need to connect, right? So VCC is power. A lot of these displays can be used with either 5 volts or 3.3 volt power. Same with logic, ground, chip select, reset, AO, which is the DC pin that I showed in the user select file. For whatever reason, this display is calling it A0. And this is part of what I want to show is like there's a lot of variation in these displays because there's so many out there. You have the SDA, which is really the data in for the secondary device, which is the display. And then you have the clock. And then you have this pin LED, which is a little confusing because you don't see this in the user file. And so this LED pin is for controlling the backlit LEDs, but in a lot of cases, it also is the enable for the display. So the display will never turn on unless this LED pin is tied to high. So a lot of times you can tie it directly to VCC, but if you have like a battery powered design or something where you want to conserve power, you would turn off this LED pin after a while if no one's using the display or looking at it to conserve power, but not in the user select file. So notice this doesn't allow you to read data from the display. And to be honest, I've never had to read data from the display. You know, it's different if you're using the touch portion, but for the graphics portion, I never had to read data. So this just has, you know, the secondary in data and the clock pin. Now the other Amazon display is a little different. It doesn't have touch capabilities. The reason it's upside down is because I wanted these words to be right side up, so that's why it's upside down. It does have SD card capabilities, so you have the SD pins. And over here, these pins are in the same order. I know the board is flipped upside down, but these pins are in the same order, and that's what I've noticed on a lot of these boards. So you can kind of plug them into your same board, and they can be compatible if you want to switch to different size boards. This has VCC, ground, chip select, reset, DC, so this is labeled more like it was in the user file. The one up there was labeled as A0, which I don't know where that comes from. You have your MOSI, your clock, your LED, and your MISO. So this one has one more pin that the other one doesn't, which is the secondary out, master in. So I don't use this pin. So in my example that we're going to show, I won't have this pin hooked up, and this other display doesn't even have it. Basically, in your user select file, or the one you name to whatever custom name you want, these are the pins you have to pay attention to. So, you know, you have your standard SPI pins, then you have some pins, chip select, DC, and the LED one is the critical one, because that's not in the user file. So you may be working with a display that doesn't even have it, but if it does have it, it's sort of a display enable disable. It doesn't consume a lot of power, it's more of a high impedance pin. And if you want the display to always be on, you can always just tie it to VCC. Okay, let's see this library in action using an example file. Now, most of you I'm sure know where to access example files in Arduino, but I'll just show you real quick. Here's the library, and it actually has a ton of examples, which is so nice, because it can do so many different things.
I see.
So we're looking at an example from this screen resolution area, and we're going to be looking
that's
at
why there's
the meters example
different
right here. So that's what I have open.
Ones listed.
So if I load this onto my board, it's going to look like this. So here's the code loaded onto my board. You can see it right here. You can see it's just showing example meters, different options that you could leverage. You know, it shows how to make these shapes, how to write text, and things like that. That's what's nice about these examples. So I have this connected to my ESP32 board.
Ooh, that's fun to watch.
And so just to give you a quick Forcetronics commercial, this is my own ESP32 dev board that I went over in a different video. You know, you can program it right from the USB interface. It has an RGB LED, and it actually can run off a battery, and it has built-in battery charging. So I do have a video on that, and all the design files for that board can be found on Forcetronics Patreon page. Notice right here, I added this code. So this is what can be frustrating about this library and some of these displays is if you didn't have this, which is basically the pin on my ESP32 that I have tied to the LED pin. If I didn't turn that pin high, you would load this code onto the display or onto your ESP32 and you would see nothing on the display. So you need to have this pin enabled. And once again, you can always just tie it to VCC. Another example I want to show is how to do a custom color. So up here, I defined a color. So the sketch already had a custom color defined in a hex format, but I added this other one right here. So I added dark red. The library uses this 16-bit format to handle an RGB color, and an RGB color is made up of 3 bytes of data, 0 to 255. And so RGB stands for red, green, blue. So I defined my own custom color, which is more of a darker red. And so I used this little recipe to combine the RGB colors into the unsigned 16-bit integer, right? Because you can see the 120, you can see the 15, and you can see the other 15. And then you can see what I'm doing is some AND operations, some bit shifting to put it in that smaller variable so it takes up less memory space. This is a way to define your own custom colors if you don't find them in the library itself. And so if I scroll down here, I actually added this code where I have the dark red. So remembering what we just saw, the meter scale had a green and yellow section. You know, green meaning good probably, and yellow meaning, I don't know, warning. Well, we can change that yellow to a red. So let's just do that real quick. All right. So here is the same example, but now this part of the scale is dark red instead of yellow. So anyway, there's a quick example how you can add your own custom color. But once again, very comprehensive library, a lot of examples to use. Okay, that's it for getting started with the TFT eSpy library using the Arduino IDE. If you have any questions, please use the comment section. And if you think there's anything I missed or anything you want to add, because there's a lot of aspects about this library, please use the comments.
77. What was that display again? Is there anything with this exact setup? This is really close. Okay, so I can install the library. Oh wait, this is with the C3, not the S3. Don't know how much of a difference that's going to make. That's almost it. I feel like this shouldn't be as hard as it is right now. Okay, let's just keep watching this one. Okay, let's just make sure I transfer those numbers in correctly. Although I'm pretty sure this is like the 4th time I've done this. Okay, so VCC is doing its thing. Ground is going to the correct place. Otherwise the screen wouldn't be working at all. Okay, this blue wire is a CS. That's chip select. TFT chip select is pin 10. That's correct. This yellow one is reset, which I am redirecting just the reset pin. That is correct. This green one is going to 12. The green one after reset is RS, which is data command also. And that's going to 12, and that is correct. Okay. And then this white one is MOC. MOC is going to 39. MOC to 39, that's correct. And then blue one is going to the clock. Clock is 36. That's correct. And LED just goes straight to power. And let's see, 37 is MISO. That is correct. Did I forget to do anything here? But there's also all of these ones here. Well, I know, because that's gonna be the same names, then why does it matter? Okay. Find the fonts, don't care about that. We're not using one of the high picos. Okay, we're not using STM32. We're not using parallel modes. We're not using a Pi display. Just checking, we're at 320 by 480. So let's try this rainbow one. Why can't it see that? Let's try reloading the project. don't know why I can't see that when it's clearly included here. Let's try building it anyway, in case it's just being weird. And it's not compiling. Going on with that? Wait a second. Oh no, I know what's going on. I was overwriting user setup. I was copying over the wrong file. There we go. Okay, so what's going on here? And I can see that it actually does some serial stuff, so we can actually try talking to it. Oh, this is not defined because it's a fucking. What happens if I? Does this actually support files? If I just. What happens if I do this? Oh my gosh, that just works? No, it doesn't. Shit. Okay, I do have to make a main.h file and then include main.h. And then is it just draw across? Yeah. Are we not including that? It did compile. Oh, I think I forgot to reload. It did compile and upload correctly. Yeah. What? That's the lazy solution for that. Okay. Hi. Trying to get this display to work. And it doesn't want to work. Still don't see anything on the display. Okay, so I've made sure that we have all the pins going to the correct place. I think I've done that like 4 times, and then I filled out this user setup thing and gone over it like 3 times. We do have the correct driver setup, or chosen, I guess. And, you know what? Let me just make sure. Okay, so my packaging says this is a 3.5-inch IPS LCD module, and it says that the driver is the ST7796. And I do have the ST7796 selected. What else? Tried like 3 or 4 different test programs from the repo itself. I have done continuity checks on the, oh my gosh, AJ, you're in the terrible spot again. I've done continuity checks on all of these, just to make sure that everything's actually staying plugged in, which it is. This is not getting hot. You are able to reprogram. I have hit the reset button quite a few times. So, I'm not sure why it's not displaying anything. Just gonna point this onto there. Just make that bigger. Okay. Let's go back to like probably the simplest example program that they have, which is, I think, that print test. Well, actually, I think that one program actually had some serial stuff going on, so let's actually do upload and monitor and see if we get anything out of that. And that could be telling us any hints about like why it's not possibly finding the display or connecting to it or whatever. Oh. Well, that helps a lot. We're just endlessly rebooting for some reason. Okay. That actually helps a lot. We'll just take like the simplest example though, and just upload that. Although, let's also do like let's connect. Again, what is it? Warning that touch is not set up, that's expected. Just wanted to get the display working first. Okay, let's try that. It is not rebooting over and over, but it is also just not displaying anything either. Now it is rebooting over and over. Why is it doing that? Serial dot print line. Just see what happens here. If we at least get that message out. Okay, let's just link this with a ton of dumb messages. And I guess that we're gonna want to have this up here, and then delay, we'll just have a delay like half a second. See how far we get until it starts rebooting. Okay, and let's reset. And let's see. What it even says here. Okay, so what if we just bypass all the shit? So I guess that we're only literally loading the whatever code that needs to run, but we're actually not running it. Actually gonna go import those build flags also from the water pump project. Alright, and then if we reset this. I don't know if we actually get anything out of that. board itself just isn't working. That'd be really annoying, but it's possible. Okay, let's just start a completely minimal project. Duplicate C. New window, copy pasta that. Don't even include those libraries. And then we'll just have it serial dot again. Let's choose a low ass baud rate for that. And then delay 1 second, and then serial.print line, hello world, and we'll just have it int counter is equal to 0, counter plus plus, and we'll just have it print out the counter. This is like the simplest fucking program that we can have. It'd be nice. Whoa, what? Oh, you know, I think it might be trying to run this over. Yeah, that's what's going on. Okay. And then let's hit the reset button. Okay, so we have the counter shit working. Cool. It's amazing. So let's maybe just kind of work backwards and slowly put these things in place and see if that works. Basically just keep adding stuff until something breaks. Okay. So that did not break. Let's include this and include this. And we need to reload project. And I wonder if we want to also include that too or not. Because I feel like that here, that library should be including SPI anyway. It does, so maybe we don't want to re-add that, because that could be maybe making it sussy. Okay, so let's try uploading that. Okay, that does not freak out. Let's try... trying to init display. Let's try tft.init and see what happens here. Hello world, trying to, okay. So it immediately did not like that. Why did it not like that? ESP32S3 ST, whatever the hell that number was. 7769. Oh, you know, we should probably transfer that setup also. We did not do that. So where is user setup.h? For node MCU, okay, we want to replace these numbers. So what happens here? Let's make sure that we're referencing the correct setup also. User setup select.h. We are doing that one, which has the correct driver selected. Alright, we're still unhappy here. This is exactly the issue I'm having. So we could try changing that definition. Use FSPI. Do we have anything about FSPI in here? Let's try that. Oh, we don't get a crash. Oh my gosh, it's showing something. It's junk, but it's showing stuff, but we have progress. Okay, cool. Okay. So it may have been just simply we needed to add that one thingy in there. Okay. So let's close the hello world and let's go back to this one. And let's just add that in here. Let me check that out. Okay. I think that may have been the same thread that I found. Oh, that's right. It's because I'm also deleting these. Or commenting them out. Okay, let's try that. Okay, it looks like that people are using HSPI or FSPI to make that work. Okay, so we have a 10-second delay that we can probably get rid of very soon. Okay, so we're still getting that staticky noise stuff. Oh, we're also just not doing any of the program. Okay, so I'm gonna go upload this, and if it's still wacky, I'm gonna go change that user setup to use FSPI instead of HSPI. It works! Oh my gosh! We actually have something on here. Hello world, 1, 2, 3, 4.56, dead beef group, I implore thee, my foonting turling drums, and hooptitiously drangle me with crinkly bindle wurple. This sounds like the Jabberwocky, but it's not. Okay, we actually have that working. That took way too long. But it works. Okay, yeah. That's good. That only took 2 hours and 10 minutes. Okay, let's try the touchscreen stuff, and I believe that the same library also works with touchscreen stuff. So, yeah, let's finally get a touchscreen example. Which... Okay, cool. So yeah, this is a touchscreen example. And, of course, that's gonna be sussy, so let's not include that because the library already does that. Include main.h. Does main.h exist? It does. Just gonna ask chat.eg to extract the function definitions out of this. Or declarations. I forgot which one. Okay, let's pop that in there. Did that not do anything? Reload project. Include main.h. Just a second, I heard something weird. Okay, I'm back. All is fine. Do we not define that, though? Okay, so... Where is this? Close you out. Okay. Am I missing anything? What is fs.h? file system. I'm just gonna try running this again. It's not including that. Include main.h is there. And we are defining those. I'm just gonna go put those up the top now. And then get touch. Is that even defined? Oh, you know, maybe it's in the wrong order. It was just that. But we still have get touch being sussy. Where is that included? Oh, right. That is likely. Okay, so I guess we do have to connect those now for it to do a thing. Here it is. Touch, CS, not defined. Yeah, it says it's not available. Okay, I should read. I'm not sure what I did that got this to work that one time, but now it's not working. Okay. Touch CS. Pin is a sort of thing that's defined in there. It's not. Okay, so is there a section here with the touchy stuff? Just add it to the very bottom. Oh no, that's setup select. User setup. There we go. Because like stuff looked pretty missing here. Okay. So there's a better spot to add this in. I think it's here. So let's see. There we go. So those 3 disappeared, but now it's just these guys. Was it the order that I had these in? Or I'll just... take all of these and put them at the top. And... okay, so let's actually connect those pins up now. Disconnect that. And... let's see. So these are the pins that we're currently using in the water project. Let's try that, actually. Is this even in the right place? It is. Because it is going to that file. Okay, I'm just gonna pop these guys to the top of the... oh, I think I just straight up... deleted those. Yeah. Okay, that makes more sense. Try the quotes now. You know, that's actually a really good point, is that I haven't actually run this reload project thing, which tends to fix those. Don't think I was happy about that still. Okay, so that's with those. Let's change it to use the quotes. Oh, it did build anyway, though. Okay. So I guess we're just gonna have to live with those angry lintings. Also, this was like redefined to be at the top anyway too, but No, it wasn't. It's moved to the bottom again. Okay, let's see how it does with that being quotes instead of... Wait a second, why? Oh, no, never mind. Okay, well, it does compile though, so maybe CLI is just being weird. But okay, let's look up the wires. Okay, so we don't need the SD card yet. We do want the touch stuff. You know, actually I'm gonna upload it anyway and see if we do get that interface that we want. Oh, it's not even connected. Okay. Oop. I did that while I was uploading. That's not good. Okay, let's make sure that we don't have anything else running. Oh, I see. That was running at the same time. Wait, I think this is the wrong project. No, it's not. This is the correct project. Okay. So... This is the keypad project. So why are we showing this stuff now? Okay, it says touch corners as indicated, so that means that that did upload. And let's actually wire up the stuff. Okay, so... touch CS. What are the pins that we need to connect? Okay, so SDA and SCL. Does this even handle this driver? FT6336U. I don't think this library actually handles that. Where is that Amazon listing? There it is. currency. So we have SDA, SCL, interrupt, and reset. So you need a library for touch. We can go with this one. Okay, let's go to there, and let's not use this whole, like, thingy. Let's go back to that, like, one weird minimal project that we had. Do I want to do that? Not sure if I want to do that. Actually, let's just... I want to see what that rotating cube thing looks like. But we could just have, like, the rotating cube and then just, like, output out, whatever areas we're touching, and then probably go from there instead of trying to work one of these examples with some driver that is not within this library's scope. Okay, cube rotate, demo 3D cube. Let's try you. Where's the copy paste button? There it is. Okay. Setup loop. Okay, let's just drag all that stuff up here. And let's upload that. I did get affiliate, actually, I think last Thursday. Yeah, last week. That makes me happy. Oh. It can't... Whoa. My cat is chewing on my foot tracker. Okay, so why did it not like that? Well, first, let's just not have this right now, and let's just upload it, because I want to see the spinning cube. Oh, hi, Sparks Maker! Yeah, when you rated me, I think the Tuesday before last Thursday, that really helped a lot with bumping me up to affiliate, so thanks so much for that. Yay, we got a spinning cube! I'm gonna go invert those colors. Yeah, actually, let's do 780 FF. Which, yeah. Let's see if it'll actually take that. I don't know what a... Wait, is that even the correct format? I don't think that's the correct format. Let's go with that. That looks weird. I didn't realize that messing with the colors would actually do that. Well, actually, let's just flip the colors, but I am confused though, because I don't think I've seen a 4-byte color definition for, unless one of these like alpha for some reason, which I wouldn't expect on a touchscreen thing like this. Is it supposed to clear the screen with something else? Okay. Well, we're not going to be using this cube anyway for the actual program that I want. Yeah, that's weird. I thought that just swapping the colors would make this magically work, but it... Oh. Well, now that I see what's going on, that actually makes more sense. Okay, well, let's just show this funny cube animation. Some of those lines are yellow, so you can like barely see them. But yeah, let's try to get touch working. Just wonder why I can't include that. Okay, those are spaces, not tabs. Let's try PO run. What if I just download this and pop it in? Okay. Examples. Read touch parameters. This looks like a lot easier of one to actually use. Alright, so let's include H. What if we want the quotes? What if I reload the project? Or just try PO run? Oh wait, I think I actually put that in the wrong folder. Yeah, I put it in the wrong folder. Okay. let's go to setup and just copy. Let's copy all of that just so that we can actually get some insight into what's going on there. Oh, and we still have to define those pins. Okay. So, pins that I'm not using right now. Am I not using 19, 20, 21, and 47? Because if not, I'll just use those. Oop. 19, 20, I am using those. Oh, but those are the potentiometers, so we're not going to be using those later. 19, 20. 21 and 47. Okay, we're not using those, so let's just use those. Because, yeah, 19, 20, we're trying to get rid of those potentiometers. Whoa. Okay. So these ones are gonna be a little longer. Okay. Alright, you can go unplug this and just wire this up at my desk. And let's see, where's that picture? Okay, so... touchscreen clock goes to 20. Touchscreen reset goes to 21. Touchscreen SDA goes to 19. And touchscreen interrupt goes to 47. Okay. Let's try uploading that, but also, wait, that example code. Okay, so we are initializing the stuff, we're getting firmware and whatever. And then here, if we get touchscreen event stuff, then we want to, yeah, we want to do stuff with that. So let's upload that. that's not the port that I want. It's gonna fail. Okay, let's try that again. Looking for port 6. Nope. And you know, we might want to actually avoid, was that pins 19 and 20? Because, oh, you know, I think I know what's going on, because those are marked here as USB data pins, so we want to avoid that. Okay, well, that explains why we're having trouble uploading stuff when we're using stuff on the other stuff. Okay. So let's not use 19 and 20. Let's try to use what's free here. Okay, so am I using 48 and 15 for anything? 48's being used, 15's being used, okay. What about... Okay, 1, 2, and 4. How about... 5 and 6 don't look like they're being used. Let's use 5 and 6. And 6. Okay. And according to that one not thingy. Clock is the blue one, and that's going to 6. And then that means that the other one is 5, and that is SDA. Okay, let's try that. Okay, we can see that serial port. We are doing that. And was it PO device monitor? Yeah, it's PO device monitor. Okay, device monitor. Oop. That's not happy. Let's make sure that everything's wired up correctly. Okay, so we have not you. So clock is the blue wire going to 6. And then a reset is the yellow wire going to 21, yes. And then SD is the green wire going into 5, yes. And then white is interrupt going to 47, yes. And let's just continuity check that. Okay. 47, that's good. This one should be going to, like... Yeah, that's good. That's good. And then should be going into. Oh. Strange. That was not connecting at all to anything. What if we put it in the one next to it? I don't know why 6 is not working. Okay. So, whichever one's above 6. 7. Just want to make sure we're not using pin 7. Shit, we're using pin 7. Okay. 7, 15, 17. Go with pin 40, actually, because that's going to be replaced with this whole touchscreen thing. Okay. So that blue guy in pin 40. Okay. Just kind of assuming there's like some weird dead spot on that breadboard. I didn't know I could do that with I2C and SPI. Huh. Okay, we have stuff going. And we have values changing depending on if I move stuff around. I have to do some reading into how to use, or I guess combine SPI and I2C stuff. Because yeah, it is addressable. How exactly does this work? It is difficult to read though, so... Okay, have to see what this actually means though. My guess is that since it's a capacitive touchscreen, then we can do multi-touch, and event ID is probably like which of the touches exist, and weight and position. Well, position's probably the middle of the position that it's guessing, and then weight is probably how, like, I don't think it's actually detecting like literal weight, so it's probably like being like, how big is the area that's being touched? Like, how squishy is the finger to whatever it's touching it, but that's just my guess. You know, it'd probably actually help to look at the documentation. Documentation. Okay. Single point and gesture touch, or 2 points. Okay, so we can do up to 2 points. And let's see. I don't think this tells us what it means, though. Okay, let's go to that bit here. And let's maybe just read the source code. Touch. What is weight, though? Passive touch weight. A touch screen. Let's see. Just gonna ask that to just okay. Combine this into a single line. Okay, we're just gonna combine all of that into a single line. And then we can see how those change as we touch the screen and stuff. That's interesting. So, I don't actually know what weight is in this respect. Okay, so we're gonna use fix with formatting on that, just so that doesn't keep changing size on us. I'm also not sure what misc is either. But position and... yeah, position makes sense though. Okay. So nothing's touching that right now. And then... what changes numbers? Okay. So it looks like position is just whatever was the last touched place for, I think that we only really care about, at the moment anyway, I think we only care about if the first... if... TD status changes to 1, and then that means that we're touching, and if it's 0, that means we're not touching, and then P1 is the position of that. And it looks like it corresponds to each, to like, the pixel values. Because our resolution is 480 by 320, and it looks like you'll be able to go from like 0 to 320 on X, and 0 to like 480 on Y. What else? Yeah, and then we could probably just treat touch as like, or the position for touch point 1 as like -1, if we're not touching anything. Okay. So that's interesting. Just thinking about how sliders will work. Because, like, buttons are easy. It's like, if we're touching within these bounds, or touching within, like, some radius of the center of this button, this virtual button, then consider it on or off or something. Yeah, I have a feeling that the slider is going to have to work how they do in VR, where it's like, if the origin point is here, and then interpolate, or I guess find what the reverse interpolation value is, or something of, from this bound to that bound, based off the center of that position. Yeah, I think that makes sense to me. Okay. Well... what else? Okay, I don't want to touch code anymore right now. I just want... let's mock up an interface. So, I have to figure out if I want this to be vertical or horizontal. Let's open up Fusion, actually. Because I think probably just basing it off of how we rotated the, whatever it's called. Based off how we rotated the PCB. Because I think the size of the screen is actually almost the same as the PCB. So, yeah, let's rotate this around so I can see it. Alright, so it's close as I can get it without, like, rotating stuff around a lot. Yeah, so... they're about the same size. The screen's a little bit smaller. So let's go to, I think it's still called, like, head test. Oop. Okay, so... a lot of this space here is actually wasted. So what we could do is we could chop that part, because the... what's it called? The... we should probably just go to the assembly. So the spout doesn't even go that far in there. So we can actually chop off that and then let the screen go in deep in here. And then we don't even have to worry about how that, how this is oriented, which is oriented landscape. We can just have the screen kind of go down in here. To find out the best way to actually erase all of this feature stuff. Without having to undo all this stuff. That's a lot of features. That's gonna be a pain in the ass. It might literally be faster just to, like, erase faces and stuff. And I don't want to do that right now. I'll do that offline. It seems tedious and not fun to watch. Yeah, so touchscreen is gonna replace all of this shit and just go right in here. But yeah, let's make an interface. And I think vertical is the way to go for this. So 480 by 320. And can we just go double? Yeah, we can. Okay, cool. So just gonna start this off on black. And I think that we want to have, just gonna have this on the side, Twitch icon. Okay, so copy, paste, remove background. That did not work at all, surprisingly, even though this is like a really simple thing. Okay, let's just do... Where's the magic wand tool here? Okay. Deselect that. And then your style, color overlay. Let's just make it white, I guess. And then YouTube icon. That is really chunky. Holy shit. Oh my gosh, stop moving, stop moving. Okay. I wanted that overlay thing to go in the group. Oops. So this is just a mock-up. Okay, cool. And let's make this 200% again. So we want to know which chats are connected. So that'll tell us if it's Twitch chat that's connected and if it's YouTube chat that's connected. And we can put this up in the corner or something. What other UI do we have right now? You have cooldown and you have fill. Oh yeah, we want a Wi-Fi connection icon. Wi-Fi connection icon. That one looks nice. Okay. select. Okay. So yeah, something like that. What are the other statuses that we have right now? We have glass exists or glass doesn't exist. And I forgot what that one other thing was. Status LEDs. Okay, so where do we define the YouTube LED? Okay, where is that defined at? Pump. Okay, load cell is 3. But what is that actually? Okay, so that's if the load cell's ready. So what's an icon that represents scale? Could go with one of... Yeah, I think I like that one. Gonna yoink you. Kind of regret setting that keyboard shortcut for duplicate, because now it's not letting me deselect, and I forgot that I actually use this key a lot. Or use that shortcut a lot. Okay, so that'll tell us if load cell is a thing. Although, really, load cell initialization has never been an issue, so, like, I don't know if we would need that. As far as if the glass is, like, present and stuff, you know, I don't think we actually need a load cell icon, because, like, if a load cell isn't working, we just flash an error saying that load cell's not working. But here, we want to know these statuses, though, live. Okay. So we have that, and then we need, like, 2 sliders for timeout and fill amount. And I think having them be vertical sliders makes sense. So just gonna yoink a simple slider. You know, actually I think I'm just gonna kind of bodge it with something like... How do I want to do this? Oh. That doesn't look bad. Okay, let's set that to, like, I don't know, 25? Can't see it right now. Why is that not changing the roundness of this? Okay, it's here. Although, honestly, that doesn't look too bad, but... okay. here. And then... yeah. And then... let's put that in a group. And then just use something like... do I have Roboto installed? I do. Let's get a monospace one. Cooldown. Minutes. I'm actually gonna put it just here, and then we can align that to there. Okay. I'm just gonna hide that away. Actually, if I hide that, then I don't think it's actually gonna use those as references anymore. Okay, yeah, that helps. So that's cooldown, and then this one you can have like fill, mount, have it be like just give it a fraction instead of percentage, I think. Let's say 1/3 glass. And then let's chop that down so that, yeah, that's about 1/3-ish. Cool. And then we have these icons, and yeah, let's maybe pull these down. Just kind of go with like a sort of minimal interface, I guess. And you know, we could actually give this more space. I don't think I have to worry about the bezels too much because we can just like I know, fill that in with like reprinted stuff or something. Okay, so this will tell us if Twitch is connected or if YouTube's not connected, and if the Wi-Fi is connected. This represents the sliders for stuff. And what do the buttons do? So, I actually forgot what those buttons. So I know that one of let's look at it. So the black button just is a way to test out if someone were to type in hydrate. So then that actually fills like some amount, and that's whatever is shown here. And then the blue one is just fill it on demand, however amount that I want. And I don't think white actually does anything. I can verify in that code. Where is this actually used? White button pressed. Yeah, white button doesn't actually do anything. But I think white was supposed to change what mode we were in. So, let's see. And let me actually shrink this down to about the size of the real screen, just so that I can, I guess, feel if this is kind of a sane thing to work with. So if this was the real screen dimensions, that feels usable for the sliders. Buttons might be a little crammed if there's more than 2. And those indicators are plenty big. Oh, you know what I could do? Let's make this text black. And then we can actually have this go down here. And we can shrink the size to like 20-point font. And instead of it being that text, we could have like some icons for like fill icon. I don't know if that's a good idea to use, because it's like paint filling. Maybe pour icon? Or maybe just like water drop icon. Yeah, let's just do that. Okay, so alright, that makes sense to me, actually. And then we can make this bigger, so it's more readable. Yeah. And then, where are those icons I put down? And so that means that the lowest bound this slider can go is just up till it hits the icons and stuff. But that's okay, because it has plenty of room, and you could have like just a little line or something that shows what the UI boundary is. Okay, and then clock icon. Not click, I want clock. Yeah, that one looks good. Okay. Cool. Alright, and then I think just maybe 2 buttons? Or no, could do 3 buttons for like mode and Yeah, like that. So this could just say something like, we can actually make the UI dynamic. So like, if we have test mode, then we can have all those buttons that we wanted, but if we have just like normal mode, then standard mode. And then let's move the sliders up. And then we can have another button for just like manual pour. Yeah. Alright, let's make that line up a bit better. It's actually kind of too skinny. I want to have enough spacing between these buttons though, so that like you can't accidentally touch one when you're meaning to touch the other. But I think that is an interface. Okay, let me shrink that down to like 3.5 inches, just so that what's going on? Okay. I think that's way too small. Yeah, that's only 3 inch. Yeah, that's 3.5 inches. But yeah, if I touch it, that's plenty of room for all the sliders and for those 2 buttons, and we can split those buttons for manual pour. If you make it a test mode, then it can have like manual pour and like simulate hydrate. Yeah. Okay. Well, I think that is an interesting interface. Okay. Cool. Alright, well, I think I'm gonna end it there. Yeah, I'll just code the interface and stuff offline, and modify the CAD model offline. Getting pretty tired, been up for a while. But yeah, alright, so, next stream, that's gonna be on Sunday afternoon, 2 p.m. Central Time. Remember that the US has switched to daylight savings, so if you're not in the US, things could be wonky for a few weeks, or if you don't use daylight savings or something, I don't know. But yeah, so at 2 p.m. Texas time with daylight savings and whatever on Sunday, gonna be working on oh, she's not listening to her wake word, on Ritsuko more. And I have decided not to use OpenClaw because it is a security nightmare. I knew this walking into it, but I actually had to use it to really get an idea of how bad it is of a security nightmare. And, yeah. It's... I have a lot to rant about it, but the three main things I saw it do before, or the two things I saw it do, and then the third thing I learned before I was like, nope, I'm uninstalling this, is, first, it was exposing API keys and tokens and secrets in plain text in the logs and in the chat interface, which is a big no-no. And then when I was asking it to expose an API point or something for Ritsuko to talk to it, it was downgrading its own security over and over, and also reconfiguring itself to lock itself out after restarting, requiring manual intervention to fix those settings. And then the third strike is that I learned that it can install skills on its own, including malware ones, and part of what I thought would keep it secure was if I only installed skills that I vetted or coded myself. And the fact that it can install skills that are very, very bad without your consent or knowledge, yeah, that's the final straw. So I took the crustacean, I put it in the pot of boiling water. We're not fucking with OpenClaw. Don't install OpenClaw. You think you can tame the claw. You can't. There ain't no laws when you're OpenClaws. So don't do it. It's not secure at all. The good thing, though, is that I knew that there would almost certainly be problems with it, so I did not ever hook it up to any of my personal accounts. The only account I think it ever got hooked up to was a Trello board that I made just for it, that had no sensitive data on it. It was connected to some API keys just to get it working with, like, OpenRouter and stuff, but I shut down those API keys. But yeah, okay, yeah, you can run OpenClaw if you want to, if you know how to completely box it in, but do not trust it on any machine that you care about, that has data that you care about. Just be ready to nuke the damn thing. But yeah, OpenClaw, bad, don't do it. But I'll go rant about that all next stream. But yeah, we're not doing OpenClaw. We are going to manually write the tooling for Ritsuko. But yeah, alright. Well, thanks for tuning in, everyone. It's been fun as always. Yeah, take care of yourselves and work on cool projects. Okay, gonna log off. Bye-bye!